Hey everyone, Nitesh this side. So let's start with the question. So the question is find all anagrams in a string. So you have given two string S, N and P. You have to return an array of all start indices of P anagrams in S and you can return in any order. So what's the question is saying? You are given a string S and you are given a string P. P is a pattern which can be in like you can arrange the pattern in any form. Basically it's an anagram. So anagram means so your anagram basically means jumble or permutation of a word. Okay, so if I take an example, let me take an example. If I take ABC, I can arrange this as BAC and I can also arrange it like CAB. I can do one more like this. So if you can see the finding the permutation of a string will cause you n factorial. Okay. So what I can do is basically find all the permutation of the P, basically the anagram string, and search in the string S. So if I found any character, I will match it. So what I will do, uh, I will basically create all the permutation, and by that I can search in the string S. Now for making the permutation, we have n to the factorial. So if we take 10 to the power factorial, you can see how big a number is. And we can do over it KMP or any search algorithm. So you can see how much time it will take. So how can we approach that? Okay, so let's see. We can optimize this also. So as you can see, let's assume like this is the length of the P. Let's see, it is call it as M and इसको हम let's say N बोलते हैं. Okay. So the maximum length of this equal to the pattern length is 4. Okay. So we need to find out this maximum length word in the string S. Okay. How can we search? So let's start with the zeroth index. We will see in this window. Okay. We'll see. Right now it's having all the four basically length of 4 and all the element basically all the character are also present in it. So we can create an output list also. We can say like this all the character are present in the string n, so we will take the start index of this. Okay, after that we will increase our window size by basically increasing the window end size by +1 and also window start size by 1 +1. So what we will do, this is now our window size. Okay, now again you see like your window length is of 4 and all character are present in that string as well. As you can see there are 3A and we have basically A, B, A. So 3A and 1B. So this is also matching. So we will add that also. Again we move forward. We are at here. We see, is this the matching with pattern P? No, it is not matching because it is having 2B and we have only 1B there. So we will not take that. We will move forward. So now our window will be this. Now we again see like all the character are present or not. Right now it is present. So we will add it in the output list also. So now this will be 3. Now we'll again increase the window size and move forward. So now we get the window as ABAAA. So we get ABAAA. This is having A as 3 and B as 1. Okay. So now we can also take that. So that will be our index 4. Now we again move forward. Okay. Now if you can see, we increase our window length by greater than n. And if you can see the pattern length is of 4 and the window length is 3. So we can't move forward. So we will stop here. So this will be our answer for this question. Now how we can solve this? Basically, we can go with two options. So first option will tell you what we can do is basically sort this a pattern first. Okay. So what we will do, like in every window, so first we have to sort this pattern P. Okay. So we will sort this. So first we will go with the sort method. So this pattern now become A, B. Okay. Now if I go to this window from the start, as you can see, so first also need to sort this S also. Okay. So this will now become A, B. Now we will check if this and this, is it matching or not? Okay. We will check if it is matching. So we will basically take that in our output list and we'll move forward. Now, what will be the time complexity for this? So if you can see for sorting the string, it will be n log n. Okay, n log n is good, and you have to do this for all the character at there. So this will cause you n into n log n, so which will be equal to n square log n. So this will be as huge. You can see like you are sorting and then again searching in the string s. So what we can do? Ca so can't we just use some hash something like so that we will not need to go further? Okay, so now we'll see the hash method. How can we optimize the sorting method to hash method? So we will use a hash of 26 size. Okay, so like A will represent by 0, B will represent by 1. So we'll take a hash. Right now all elements are 0 inside that. So we'll loop over our pattern. So first we'll see like this is having a character A. We'll check, we'll increase the A by 1. So A by 1. Right now it's 0, so it will be increment by 1. Again, we'll found like this A. We will increase this by 1, so it will become 2. Again, we'll go to B, this index. So we found that this is B. So we will increase this by 1. Now we'll see this is A. So we'll increase this pointer by 1. So basically now this will become 3. Okay. Now what we will do, we will take 2 pointer from here. So this will be our window start and our window end will also will start from here. So we need to check basically three things from here. First, we need to check whether this A is it in the pattern or not. Okay. Second thing we need to check, is this character do we need in the pattern or not? Or third, is the window size is greater than the size of the pattern. So we'll do the thing. Okay. So first we will check, is this A we need in our pattern? Yes, we need it. So whenever we need it, we need to check, we will increase window end by 1. Okay. So now window end will point here. 1 second. So now window end will point here. Again, we'll see here from here only. We will check, is this A, do we need like whenever we checking the element also we will decrement it from the hash also. Okay, so now this will become 2. Okay, now we'll check this A, do we need in our pattern? Yes, we need. So and this A is also greater than 0, so we can take that. So what we will do, we will make this, we will remove this 2 by decrease by 1 and we will make it as 1 and increase our window end pointer to this. Okay, again, we'll see, is B is greater than 0 in the hash? Yes, it is greater than 0. So what we need to do, we need to decrease this by 0. And one more thing we need to check, is this window length, basically window end minus window start, is it equal to pattern? If it is equal to pattern, that means we found a string. But right now, if I do 2 minus 0, it is equal to 2. So we will not take that. So what we will do, we will basically increase that window end. We'll again see, is this A greater than 0? Yes, it is greater than 0. So we mark it as 0 and we'll increase the pointer by 1. Okay, at this time we'll check, is this window end minus window start equal to m, basically this m. If it equal to m, that means we found one anagram that is present. So what we will do, we will take the index of window start and we will just insert in our output list. Okay. Now we will again see. Okay. We will see. Is this A? Do we need in our hash map? Basically, is it greater than zero? No, it is not greater than zero. So what it means, like our window size is greater than the pattern. So what we need to do, we need to increase our window size by one. Now window size will point here, and whenever we increasing, we need to uh, increase that character by one also. So now this will become one. Again, we'll move forward and we'll check, is this a character greater than 0? Yes, it is greater than 0. So we will mark it as 0 and increase this pointer by 1. Now we will check window end minus window start. So 5 minus 1 equal to 4. That means it equal to pattern length. So we will take that also. Similarly, we will go forward. We will increase this by 1. Basically, we will check, do we need this B in our pattern? Yes, we need. But can we take it? No, because our window length is greater than 0, so we need to increase this window start by 1. So as you can see, this is the approach which we follow. So let's go with the code. Okay. So as you can see, I have taken a length n from the string length and m for the p length. Okay. Now we'll take a list variable and we check whether the s equal to null or the string length equal to 0 null. So we just return the empty list from here. Okay. Now here I've created a hash of 26 character, and it's basically I will do it like if it is a, so I will do a minus a, which represent 0th index in the array. So my array will be like 0 to 26. So each like 0 will represent a, similarly 1 will represent b. So this is as simple as that. So you can see in the pattern, I have taken the character, each character from the pattern and insert into my hash. So at this point, hash is created. Okay. Now I take the two variable that I am telling about you, that window start and window end. So we will take a loop over window end less than the string length. Okay. So what I was mentioning, we check the three condition. Okay. We will check uh, whether this is a valid anagram or not. Okay, so we'll check first whether it is a valid anagram or not. If it is a valid anagram, then we will do into something. Second thing I am also telling, if the window is of size 0, that means like this character is not needed in the pattern, so we increase both the pointer. Okay, and the third option that I was telling, basically if the window size is greater than the pattern, so reduce the window size by increasing the window start pointer and also the increase the hash of that pointer also. So let's see the valid anagram loop also. So we need to check if the current character that is at window end, is it greater than 0 in our hash. If it is greater than 0, what we will do, we will decrement the hash of that value. And one more thing we need to check, is the length of the window end and window start equal to our pattern length. If it is pattern length, that means we found our anagram in the string and we will insert into the list. So similarly, we'll move forward and we'll do the same for all the rest of the string. So let's run the code. So as you can see, we getting the same output as I was explaining. So let's submit the code. As you can see, the code is submitted, and the sorting approach I was telling you. So basically, it's not it giving me time limit exceed because it is taking the complexity of n square log n to first to sort the string and then basically do for all the elements. So that's why I use this approach. Hope you like this video. Thanks for watching.